Hi, welcome to this lesson on trigonometry. We've already introduced the idea of the tangent ratio and the idea that we can connect a fraction of two sides of a triangle to a particular angle. And we came up with the formula that we've got here in the green box, that the tan of x, tan short for tangent, the tangent of some angle is just basically this ratio that for every angle is the same. And we've labelled our sides opposite, adjacent and hypotenuse in order to help us understand which sides we're going to consider. So in the previous lesson we had a look at the fact that the letter we were working out was always on the numerator of the fraction. And in this lesson we're going to work out what happens when the unknown, the letter in our diagram, is actually on the bottom of the fraction. It's just a slight change in how we work out the final answer. So let's have a look at example 3. It says calculate the length of the base of the triangle. So here we've got a right angled triangle. The height on the left hand side is 16 centimetres and we've got a marked angle of 30 degrees. We've also got a little square which reminds us that it is a right angled triangle. So I'm going to label my sides first of all because I know I'm going to use trigonometry. Always we can label the side opposite the right angle as the hypotenuse, and I'm going to use HYP. And the side opposite the given or marked angle is the opposite side. And the other side is the adjacent side. Okay, so now I can introduce my formula, and it's the formula that's in the green box. So I can write it down as it is. It says tan of x is equal to opposite divided by the adjacent. We know that the tan of a particular angle is a fixed number. Okay, so what we need to do is to substitute in to our formula the things we know. We know that x is the angle in the triangle, so that's the tan of 30 degrees. Remember, your calculator has that number, is equal to, the opposite side here is 16, and the adjacent side is, we don't have anything along the adjacent side. So what we need to do is to introduce a letter to stand for the number that we want to work out. I'm just going to call it A. You can call it any letter that you like. So here's A here. So we've now got a situation where, remember when we had a number on the bottom of the fraction, we just multiplied both sides by that number because they cancelled out. Well, we do the same thing here. In this equation where the right hand side is dividing by A. Now it could be any number. It could be divided by 5 or 7 or 9, but we don't know what that number is. So we do still multiply to cancel it out. We're still going to say, okay, we want to multiply by do the opposite operation or inverse operation, and therefore we have to multiply by A, whatever that number is, because that still cancels things out. We divide by A and multiply by A will simplify to 1. So that gets rid of the fraction, but of course in order to balance the equation I've actually got to multiply both sides by A. So I have to remind myself that I have to multiply the left hand side by A as well. So what have I got here? I've got A times tan of 30 degrees equals, all I've got on the right hand side now is 16. So I don't have my calculation ready to put into my calculator yet because we always want the letter on its own, and at the moment A is being multiplied by the tan of 30. All of a sudden the A has appeared on the left hand side because we've multiplied both sides by A. So what do we need to do? We need to do something that gets rid of the times tan 30 beside the A, because we just want A on its own. What do we do to undo a multiplication? Well, we have to do a division. So what we do here is we're going to divide by tan 30. So we've got an extra step of working when the letter is on the bottom. We're going to divide both sides by the tan of 30 degrees. And the purpose of that is then they cancel out, and I'm going to be left with A on the left hand side, which is great. And on the right hand side I've got 16 divided by tan of 30 degrees. Now that is something I can put into my calculator. Okay, so I take my scientific calculator, make sure it's in degrees mode. Remember, it should have a wee D at the top. We talked about this in the one of the videos here. You've got D, G and R are possible little letters on your calculator screen, or maybe DEG, it might be DEG, GRAD, or RAD, RAD. If you've got to have we're working in degrees mode, so if you don't have it in there, you're going to have to change mode, and I talked about that in the last video. So 16 divided by, press the word tan on your calculator, and then the number 30 equals, and we get the answer 27.712. I'm just going to write it at the side here, I've kind of run out of space. A equals 27.712. And remember, we're usually rounding to but one decimal place. We cut it at 27.7. The one says round down, so I've got A equals 27.7 what? Centimeters. Centimeters to one decimal place. And that's us worked out the length of the base of the triangle. Okay, so we've got one extra step. Instead of just doing a multiplication of both sides, we also then have to do that division. Okay, let's try another example. Calculate the length of the side marked T. Okay, it's a right angled triangle. We've got one side length and we've got an angle, so we can use trigonometry. I'm going to label my sides first. Maybe you could copy it down, pause it, and try it yourself. Maybe take it one step ahead as I go along and see if you can do it first. So if I label the sides here, then what I'm going to do is there's a right angle at the top. So this time the hypotenuse is down here. The marked angle 71, if you got away from that, you've got the opposite side, and the other side is the adjacent side. Okay, we're going to write down our formula. We only have the one, and it goes like this. Tan x is equal to opposite over adjacent. We've got three things we need to fill out: x, opposite and adjacent. It tells us at the moment that x is the angle, that's 71 degrees, is equal to opposite is 5.7, and the adjacent is t. So again, we've got the letter on the bottom of the fraction rather than on the top. So to get rid of the fraction, we do the opposite of dividing by t, which is multiplying by t, and we do that to both sides. And if it helps to remind you, we're cancelling these out, put a wee line through them, that's fine. What have we got on the left hand side? We've got t multiplied by tan 71 degrees equals 5.7. Okay, I haven't got t on its own, it's on the left. It's multiplying by tan 71. So what do we do to effectively undo that tan times tan 71? Well, the opposite or the inverse of multiplying by tan 71 is dividing by tan 71, but we've got to do it on both sides. And again, where you're doing the opposite processes, you can score them out to remind yourself that they cancel out. And if we refresh that, we've got t on its own equals 5.7 divided by tan and 71. We've got t on its own, we've got the letter on its own on the left, and on the right hand side we've got a calculation that we can do on a calculator. So I take my scientific calculator, 5.7 divided by the tan button, and then 71 equals, I've got 1.962 and so on, 1.962 and so on. It's okay to write it out in full first of all. We're going to round it to one decimal place. So we've got 1.9. The 6 tells us to round up, which would have to push the 1 up to 2, so it becomes 2.0. 2.0 meters is the units of measure to one decimal place. There we go. I should say one thing about calculators. Depending on your calculator, you might have to put the 71 in first. So if you've got an older calculator or one, you just have to watch which, or try it which way works for you. So you might have to press the 71 button and then tan. Most of the newer calculators, you press the tan first. So you just have to make sure that you work out how that goes. Okay, so there's two examples. What I've got now is a screen where I've got 6 different triangles, and the task is here. I haven't written the instructions, but we're going to, for each one, you're going to calculate the length of the side marked with an X. Okay, so side marked with that letter. Okay, so I'm going to get you to pause this. I want you to try and maybe do the first one, and then you can check my solution to it. Try the second one, check my solution, and then you can maybe try the other ones and then check back. So the solutions are coming up, and you can work through them with me and spot if you've got any errors along the way. Okay, so pause the video, give this a go, and then check against mine. Okay, so here's the first 3. Let's have a look at this first one. Just work through them quite quickly. We've got right angle is hypotenuse, marked angle is opposite, and the other one is the adjacent side. So my formula is tan x equals opposite over adjacent. And this time the ratio is to do with the angle 25 degrees. So it's the tan of 25, which my calculator knows, is the same as the ratio of these two sides. Opposite is 4, and the adjacent is x. So here's my letter on the bottom of the denominator. So as we talked about in my examples, we want to first of all multiply both sides by x. Try and make your x's different from your multiplication signs, otherwise you just get xx. We're doing that to cancel out those two x's, so we can rewrite our equation on the left hand side as x times tan 25 degrees equals 4. We now need to get rid of that times tan 25, so we do that by dividing. That's the opposite operation on both sides. Tan 25, in order for those two to cancel out. So if I refresh my equation, I've only got x on the left equals 4 divided by the tan of 25 degrees, which I can do on my calculator. X is 4 divided by the tan of 25, and that gives me 8.578. 8.578, and so on. Round that to one decimal place, it's 8.5, and the 7 tells us to round up, so it's 8.6 units are meters, and I'm explaining to one decimal place. There we go. Did you get that? If did, you can have a go at the next one. Okay, so here, let's label the sides. Hypotenuse, opposite, and adjacent. You may already be thinking, what happens if you want to work out the hypotenuse side? And if you are thinking that, then that's great, because you're being curious that all at the moment we're dealing with the opposite and adjacent. That will come, and we've got a different formula for that, but we're just introducing it with this tan ratio just now. So let's use a red pen. So we've got everything set up. My formula is tan x equals opposite over adjacent. Fill in what we know. We know the angle is 75. My calculator knows what that number is for 75 degrees, and I know that my ratio is 12 over t on this triangle. So I've got divided by t, so I've got to multiply both sides by t. And that's going to leave me with t times tan 75 is equal to 12, because I didn't square them out, but we're basically doing that. And then what we're going to do to get rid of the tan 75 here, to allow us to cancel it out, we're going to do that. They divide down to 1. And so, what we're left with here, oh, I forgot about my red pen. We've got t on the left equals 12 divided by the tan of 75 degrees. Now I can use my calculator. 12 divided by the tan of 75 degrees, 3.215, 3.215, 3.215, and so on. Cut it at 1 decimal place. We've got 3.2 centimeters to 1 decimal place. And lastly here, let's have a look at this one. There's my hypotenuse. There's the opposite. There's the adjacent. And I'll use green for this one since we've got a green triangle. Here's my formula. Tan x equals opposite over adjacent. Fill in the angle that's marked as 57 degrees, and from our triangle, opposite is 37 millimeters, and the adjacent is the letter A. We're dividing by A here, so that means we've got to multiply by A on both sides, so that they will multiply or cancel to 1. I'm using green. So what have I got? On the left hand side, A times tan 57 degrees is equal to 37. How are we going to solve that equation? We're going to get A on its own by dividing by tan 57 on both sides. Oop. Getting a wee bit scrappy there. They simplify to 1, and what have we got? We've got A on the left, and we've got 37 divided by the tan of 57 degrees. I can do that on my calculator. 37 divided by the tan of 57, 24.028. Does that make sense? Yep, 24. You can always, if you check your answer, it should be kind of sensible to the diagram that we've got. If you notice in each case here, the answer X in the first one does look longer than 4. The diagrams aren't always to scale, but they should be roughly correct. So in this case, the X line clearly is bigger than 4. That makes sense. In the second one, our T is 3.2. Yeah, we would expect that base line to be smaller than 12 centimeters. So it's about a wee bit of common sense without being too beholden to the picture. So 24.028, we can round to 24.0 millimeters to 1 decimal place. Okay, so that's the first 3. I'm going to put the next 3 up, and again, if you haven't already tried them, give them a go, and I'll just quickly go through them in a moment. Okay, so let's label our sides. Oops. Hypotenuse, opposite, adjacent. Write down the formula. Tan x is opposite over adjacent. Substitute in tan of 63 degrees, opposite is 7.6, adjacent is D. So we're going to multiply through by D in order that they can cancel out. Rewrite the equation. Examine the equation. How do we move forward? We want to have D on its own, so we're going to do the inverse operation to multiply by tan 63, which is divide by tan 63. We'll get D on its own. There we go, 7.6 divided by the tan of 63 degrees on a calculator. What have we got? 7.6 divided by the tan of 63 degrees. 3.872 will do me. 3.872. Do you know what I'm going to do? We're going to do it to three significant figures, I think, in this one. Just to mix it up, three significant figures just means that we're going to take the first three digits on our answer, the first three non-zero digits here, and rather than just a decimal place, just to remind you of a different rounding. So there's 3.872. If I were to cut it after three digits, I would cut it before the 2. The 2 says round down, so D would be 3.87 meters to 3 SF significant figures. Okay, you may or may not have come across that, but if you have, then let's practice it. Second one here, let's have a look at labelling the sides. Hypotenuse opposite adjacent. Let's write down and then we're dealing with 19 degrees in this one. The opposite is, oh, oops, I've made a mistake here, haven't I? That's not going to work. So you might have spotted that the 14 was meant to be up there. Okay, I'm not going to redo this video, I'm just going to write it in like that, so you probably come thinking I can't do it. The reason is it's not you, it's me. So that's 14 over n, and multiply both sides by n, and we end up with n times the tan of 19 is equal to 14. Divide through by the tan of 19, so they cancel out, and we've got n is equal to 14 over the tan of 19 degrees. I can do that on my calculator. 14 divided by tan of 19, 40.65840. 0.658. I'm going to do it to three significant figures. So I start at 4, first significant figure, 0 is the second significant figure, 6 is my third, so I'm going to cut it after the 6. The 5 tells me to round up. So we've got 40.7 kilometers to 3 significant figures. Okay, sorry about that wee mistake there. And the last one is hypotenuse opposite, and where's the other one? Adjacent. Write it out. Tan x equals opposite over adjacent. Substitute in tan 47 degrees is equal to 245 divided by h. Okay, multiply by h on both sides because they cancel out, and that leaves us with h times the tan, of 47. There's only so fast you can actually write on these things, equals 245, and we then want to divide by tan of 47 on both sides, which leaves us with h is equal to 245 divided by the tan of 47 degrees. And get that on my calculator. 245 divided by the tan of 47 is 228.46. Okay, 228.46. Now, Three significant figures, 2, 2 and 8, will actually take me to where the decimal point is. The 4 next digit tells me to round down. So in this case, the answer is just a whole number, 228 millimeters. To 3 significant figures. If you've rounded them all to one decimal place, and you know you've got them right, then that's absolutely fine. Okay, so there's a lot of practice on doing this particular type of calculation, and I hope you've got these right, and then we're ready to move on. Okay, thanks for trying.